right? I don't have anything in it. And it has some different areas we need to recognize, all right? And so on your periodic table, you have things listed as 1A, 2A, all the way through 8A, Roman numerals. And a lot of times we just talk about those first two columns and the last 8 columns. That's kind of what we talk about. We talk about these first 2 columns a lot because we can look at some characteristics of these first 2 columns and these last 6 columns, and we can really talk about those elements and some specific properties chemically that they have. Okay? So these are called representative elements. Okay? Or what those are called. So representative elements, when you hear that, you kind of know, okay, those are the first 2 groups of elements and the last 6 groups of elements. And those are most of all of those you have to know the symbol and the name for the test. If you notice, I gave you 1 through 38, and then I gave you 46 through 56, and then 78 through 88. So basically, I'm giving you all the representative elements that that you have to know on the periodic table. Okay, so those are called representative elements. Okay? So groups 1 and 2, 13 through 18. Those are representative elements. I didn't give you the 1A and the 2A and that type of thing. Now, when I say groups are columns up and down. When I say group 1, that means this is group 1, group 2, and then this is 1 through 10, or not 1 through 10, 3 through 12.
Yeah.
And then we've got 13, 14, 15, 16, 17, 18. Okay? And so that's how we identify the groups. Okay? So if I say group, 4, you know where to find that on a periodic table. It's kind of like on a map. Did you guys ever use the maps where on one side you had A, B, C, D, E, F, G, and on the top you had 1, 2, 3, 4, 5, and then you say, okay, go ahead and find, 7D. 7D, and you go down, and there it is, okay? That was an old school way in which to do maps. We didn't have Google Map or anything like that. You had the map in front of you. And it was kind of funny, on the side they would have these towns, and well, this town is in the location on this map at 5G. You go, okay, shoot, okay, you found it that way. Don't have to worry about that anymore, okay? This elements in here, these are called the transition elements. These are all metals right in here, the transition elements. They all have kind of, their characteristics chemically are a little bit different than representative elements in some areas when we take a look at their electrons and how many electrons they kind of give up when they react. So those are called the transition elements, and they would be groups 3 through 12. Okay? Hey, another group of elements, when we take a look at them, it's called the Lanthanide Series, and down here is your lanthanides. and this is your actinides. Now these are the last group of elements that were found. So you look at the actinides and that was really the last group of elements that were discovered in like the early 1900s. Why? Well, they're so close in properties with one another, they were hard to isolate. Okay, the noble gases was another group that was really hard. Well, they were found later than all the other elements, and the reason why that because the noble gases aren't found in any compounds, and so a lot of these are isolated from their compound form. Lanthanides and actinides, they're called the rare earth elements. So these two are called the rare earth elements. And it's not because, well, they're the heavy metals. We've got a place in Beatrice that they actually they try to take rare earth elements and find them because they're hard to isolate and they're pretty expensive. And they're used in a lot of technology. So a lot of these rare earth elements down here in the lanthanides, they're used in a lot of technology. Cell phones, computers, those type of things. Okay, so then we got our groups. We got group names. This first group is called the alkaline metals. Okay, we'll give you information on those later on another form. This is called the alkaline earth metals. So they have a real similar name. They just extend it out a little bit. So that's alkaline earth. You can get it in there. So that's called the alkaline earth metals. Another family with real similar characteristics all the way down. So these families have characteristics all the way down that are really similar chemically and physically, and physical characteristics, but a lot more chemical than physical. And then group 17 is called the halogens. And this group is called the noble gases. You guys have heard those, right, before?
Yeah.
Okay. So, I mean, it's not foreign to you, some of this stuff. So the halogens, they're extreme. You don't have to write this down now because we'll do it later. But the halogens are extremely reactive. I believe they're all poisonous in their pure form. So if you breathe in chlorine in its pure form, chlorine gas, it'll cause your lungs to explode.
A little? Like a lot? Or just a little bit?
It'll kill you. So they used to use it in German warfare in World War I. They would take and release the gas is heavier, and then the prevailing winds on a day that was blowing toward the trenches, because it was trench warfare, would blow toward those trenches and just go down in the trenches, and if you didn't have your gas mask on, or didn't put it on quick enough, you'd breathe it in and it just causes your lungs to start to dehydrate and explode. Not probably a very good thing to happen. Iodine is poisonous as a gas. Bromine's really, really nasty stuff. I was working with that one day and I had it open and I didn't have it under the hood and my forehead started itching. I'm going, that's not good. Okay. Because it started reacting with my skin.
What?
Yeah. Yeah, pretty nasty stuff.
Did anything happen?
No, I got water on it right away. I knew what was going on, you know. Because bromine's a liquid at room temperature, but it doesn't take much to go to a gas. You know, it's one of those things that doesn't hold together real well and evaporates pretty quick. So I knew right away I was in a little bit of trouble with that and went over the fume hood and got that taken care. But most gases that have a color to them, you don't want to breathe in. I mean, duh. But they're mostly poisonous. So I would say if it's a colored gas, you'd want to get away from it because it's going to be poison. Now, there's other gases that are transparent that are poisonous too. So it's not saying that That you know, the noble gases are very unreactive. They're used to stabilize things. I mean, if we want to stabilize an element that's really reactive, like an alkaline metal or something else, we would put it in a noble gas, because a noble gas is kind of like an insulator. It says, you know, we're not going to react with you, and we're going to go ahead and seal you off from things that can, and that's what a noble gas is. So there's these properties that these elements have. There's good reasons for their properties, and we use them in a beneficial way a lot of times. Some ways, this was like I said, this is the halogens. Somebody came up with a way, to make chlorine gas, and then they used it. That was the first, what they call chemical warfare that they had. So, all right.
It's legal in the world.
So the next slide. Let's see. Do I need a? I'm going to go ahead and make a. I should have made a copy of this earlier, but on your periodic table, I'm going to go ahead and make a copy of this here. Let me see. Okay, so you guys can use yours if you want to. I'm just going to make this less messy. Okay, and I'm going to get rid of some of these words. So now I'm going to go ahead and look at this periodic table and group them based upon some general properties that they have consistent within the grouping I'm going to give you. And you've heard about these too, all right? And so I'm going to talk about metals, nonmetals, and metalloids, and this is what your lab is over tomorrow, okay? I would say 2/3 of the elements are considered metals. So 2/3 of the periodic table are made up of metals. There's only about, I think, 7 or 8 what we call metalloids, and then not too many more nonmetals that we deal with. So now when I circle this, I'm going to do the best job I can in which to encompass everything when I circle. And when I do this, I want to go ahead and show my staircase. Now, you guys don't have a staircase, and I don't mind if you put one in. I'm going to show you here kind of how that staircase will kind of work. So if you want to, you can wait to kind of see how this is all going to fit in. So, I'm going to do is I'm going to circle kind of this general area right here. And include aluminum in that. So, this whole area, these are the metals. Metals they conduct electricity. So that conductor in the back, it would show number 4 every time. It would show both lights lighting up when I would put anything up against any of these elements. They all are good conductors of electricity. If I add energy to them, like heat energy to them, they heat up really fast. They're good conductors of heat. They send heat from one end to the other really fast. Okay, so they're both good conductors of heat, and that means they'll conduct heat away from your body really good too. So if you pick up something that's metal and it's cold, it really pulls heat from your body fast. Okay, so like if it's outside and you pick up something that's metal versus something plastic, you know the difference, because the metal is like, okay, wait a second, how come my hand's sticking to it? Because So metals are very good. They pull energy out of things really quick. They do a good job doing that, and then they conduct electricity really well. They also can shape really well. They can bend without breaking. It's called malleable. They're ductile, which means you can pull them into thin wires really easily. Okay? A lot of times they're shiny. They have a luster. They have ability that when you will shine them up, they have a shine to them unlike other elements would have. Okay? So we say that they have a luster to them. Okay? They all kind of react a little bit differently, but a lot of them have high density, but not all of them. Okay? So then we've got this along the staircase. Excluding aluminum, if element is in these locations here, those are metalloids. Okay, so what are metalloids? Well, metalloids are they're called semiconductors because they conduct electricity but not as good as metals. They're kind of shiny, but they don't have the luster that metals. They're kind of like, maybe you had a sibling come through school and they were really smart and they did really well in school, and maybe you're not. Maybe teachers, they shouldn't do this, but they compare you to them, and then they think you should be up to their level. Okay? Just as an example. And you can say, well, I'm not as good in athletics, I'm not as good in this, There's probably something you're a lot better at than a sibling. But it seems like you're always compared to that sibling, which is unfortunate sometimes. The metalloids are like, compared to metals, they're very useful because we want semiconductors. We don't want something to conduct electricity sometimes very good. We want situations where they conduct fairly well. Okay, so they definitely have their uses. Okay, but that would be the metalloids, and aluminum's not part of that grouping. So if you remember, if you want to put your staircase down, it starts at the top underneath what we call boron, and it goes down all the way to the bottom there next to radon. Okay? And so this area to the right of that, what do you think those are called? There are some gases, which would mean the red ones are gases, but they're not all red. So these are called the nonmetals. So guess what? Nonmetals means opposite of metals, basically. Good poor conductors, good conductors. So these are more like, nonmetals are more like insulators, where they don't take heat away from things. They do a good job of being something that you would, if you put your hand on them and hold them, they won't draw heat out of your body. Okay? They're brittle, where these are malleable. These are kind of dull looking. I mean, dull mean they're not pretty. Dull means they don't shine. They don't have a luster. So if you know what metals are, then you can take nonmetals and they would be opposite. Okay? Any questions on that? So if you look at it, most of the periodic table is metals. Then you got metalloids that have properties of both. They kind of have some properties of nonmetals, some properties of metals. They're kind of in between. And then, so the lab we're going to do tomorrow, you will have to determine, I'm going to give you 8 elements, and you have to determine if it's a metal, nonmetal, or metalloid based upon characteristics it has. Okay? And most students do really well on drawing out that conclusion. Okay? Before you go, I'm going to go ahead